All right, these are the 3.8 notes. The lesson here will be on transformations and the circle family. This is our final set of notes for chapter 3 and our final family of graphs to talk about, which is the circle. If you go back through the last several videos and lessons, we've been talking about transformations now since lines in motion. Then we did quadratic family, parabola, the root function, the absolute value. And the transformations that we've covered at this point is really all of them we're going to talk about, which is left, right, up, down, and reflection, and then dilation, changing the size of a graph by a scale factor. So we're basically going to run through most of those with the circle family. And like the other days, we start by talking about just the equation and the graph and how that all works. And then once we feel like we're comfortable with that, the rest of the notes will move into doing the kind of the similar stuff we've also done the last several days, which is here's an equation, draw a graph. Here's a graph, write the equation, and then some variations of the equation. Also based on stuff we've been doing for the last several sets of notes. So we'll start with the basics. What's that equation of the circle about? How do we use it? And then just move through the rest of the notes talking about our transformations. So let's get going. So our basic circle, or our parent circle, we call the unit circle. So like all your Ds, all these lessons we're talking about families of graphs, we've had a parent. And our parent equation looks a little bit different. It reads like this: x squared plus y squared equals 1. The reason it's called the unit circle is unit in this case means radius 1. So we've got a circle with radius 1. And when you see x squared plus y squared equals 1, that will be your radius. So, essentially it's as simple as this. As I move around the circle, 1 in any direction from the origin from 0, 0. The idea of a center point will replace our vertex for most of our other graphs where we had a vertex. And eventually here in a minute, we'll call it h and k even too. So it's not a vertex, but it's a point that we can treat like that, especially when we start doing shifting left, right, up, down, and want an equation right, a shifted graph. But the basic one, pretty simple and very easy to draw. When you're drawing a circle, start your center, travel out, basically left, right, up, down in each direction, radius, whatever, in this case radius 1, draw your circle. When you guys are drawing these yourself, of course I've got the nice neat ones that are pre-made. Just do the best you can. We're not expecting it to be perfect, but as long as it looks somewhat like a circle, we're good with that. Okay, let's get into some of the other things we can do here. And the first thing we're going to do is change the size of the circle, because of course not every circle is radius 1. So when that number changes, that changes our equation just a little bit. And so we're going to go away from 1. If our radius gets bigger, then we just call this an r squared. We use r squared, x squared plus y squared equals r squared, to talk about the radius. One thing you have to kind of catch as you go is that if you're thinking this is the radius, no it's not. All right, that radius is actually what you get by solving this little mini equation. And you guys will get, probably won't need to solve any equation. I'm sure you just look at the number and go, hey, what's the square root of that? But that's what we're doing. Take the square root, right? So square root, radius is 5. Again, sketching, very easy to do. Once you decide what your radius is from your equation, travel out in each direction. So work your way around, hit all these spots, plot some points, draw your circle. So I'm going radius 5 in every direction, and then my circle. So I'd say of all the graphs you guys have looked at and worked with, circles are probably the easiest. Visually very easy to figure out, very easy to draw. Anyway, the idea of this slide is that you're working with circle radius, something other than a 1, not a unit circle, and when we have that, we change out the 1 and call it r squared. We could do r squared with a unit circle too, and put a 1 here, and if you said r squared equals 1, you still get a radius of 1. But when it's a unit circle, we don't bother with the r squared. Okay, let's try some other things with our circles. So here we go, right? Given the graph, write the equation, and of course the first thing you're going to want to do is that important number is what is r, what's your radius. X and y we don't need to do anything with right now, and the reason we don't is because we're not shifted, so 0, 0. When you have just plain x and plain y, x squared y squared, that means your center is at 0, 0. So r squared, first thing to do is go figure out your radius by counting. Again, real easy, right? 3 in every direction, so I got a radius of 3. Nothing complicated there. And then when you go to plug in, just remind yourself that that is r, not r squared, and you have to square that. So your final equation is x squared plus y squared equals 9. So here's the equation of that circle. Okay, again, I think very easy to work with. Pretty straightforward stuff so far. Let's try some more. So the other thing we can tie in is the dilation idea. Now when you do dilation, it might seem a little strange at first because we're upsizing the circle by a scale factor. And we have that kind of same look that we have with absolute value. And the a and the b are the scale factor, and they do upsize it if the number is bigger than 1. when you look at this, it reads like radius 1. You sort of feel like you got like the last equation, hey, x squared, y squared, and r squared is just a unit circle. And what this really says is we're dilating the unit circle. So we're going from radius 1 to a scaled up version. That scaled up version is happening right here. In a minute, I'll show you how this actually is just another version of x squared plus y squared equals r squared, and how that produces the same type of circle we just talked about in the last slide. But for now, let's just work with this. So we're saying, when we say radius here, we're actually saying radius 1 is the start, or we're working with the unit circle, and we're going to upsize my unit circle, dilate it. The dilation is, what is the factor? How does it get dilated? And this really is the idea of making it larger. So whatever that denominator is, whatever your A and your B is, that's the size, the increase in size. So we're going from unit circle radius 1 and we're upsizing it to radius 2. The A distance, A would be here and here, B here and here. As long as those numbers are the same, you're definitely going to get another circle. Now you might go, well, again, how does this relate to the x squared plus y squared equals r squared? Or can we even just come up with another version of the dilated version that shows us that? And you can really easily. So we're going to walk you guys through that and show you like how do we relate this equation to this version. So what you do is you actually start with this, and we're going to square what's here. So that's squared. I'm going to distribute it into top and bottom, and I'm going to get this. So if I square everything here, I have that, square all of these. And then what we're going to do is get rid of our fractions. And the way you get rid of your fraction is multiply through by whatever your denominator is. So now we're going to go ahead and multiply through by that. When you multiply through, the 4's would cancel here, the 4's would cancel here, and I would have 1 times 4. Now if you look at that, the fractions being gone and equals 4, there's the sort of the version of just x squared plus y squared equals r squared, where we're not talking about it as being dilated, but we're still saying, hey, it's an upsized circle, just like we had in the last example. And you can go out here and go, oh, that's my r squared, so my r must be 2, radius 2. So the dilated version of a function, of an equation, is just another version of something that would do the same thing for us if it didn't read with these scale up or upsize. So we're trying to get you to think a little bit about, how would you upsize a unit circle by a factor of, and then connect to the idea of a similar equation that would do the same thing. Okay, let's go ahead and keep moving here. So a question for you guys, just think about it for a second, is what if you only upsized one of the two? You only made horizontal bigger or vertical bigger. What would you have? And if you think about that for a second, if you're trying to put a name to it, I'm sure a lot of you guys are going, well, I can visualize it, I can draw it, it's an oval, it's a whatever, we call it an ellipse. You can call it oval if you like, but if I just did the blue and I only upsized from unit circle radius 1 to 4, it would only get bigger horizontally and I'd have an ellipse. On the other hand, if I did the red one and I only upsized vertically by 4, I'd have an ellipse going this way. We're having you guys work with circles, of course, but if you only upsize one or the other, you no longer would have a circle. So that'd be dilating in one direction. Now, kind of circle, no pun intended, circle back around to the H and K idea, right? So with the H and K idea, we're going to talk about a shifted circle. So we're going to go back to that x squared plus y squared equals r squared kind of look. We can do shifted with a dilated version, which we'll talk about in a second, but we'll kind of keep floating back and forth between the two formats, just so you guys can see them both and see how they relate. This is not hard to do either. Now your center just has been moved away from 0, 0. And like doing vertex in a parabola, vertex in an absolute value, vertex in a root, that center is going to be your new location. Then from there, you can travel out, your radius, and there's your circle. So it doesn't change the radius really as far as how we visualize that, but where are you at, right? So where's my center? 4, -3. So I'll pop those up. 4, -3. My radius, of course, still just countable. Count that in each direction. Or you got a radius of 3. And then drop your numbers in. Now when you go to drop them in, like in the past, if one of these two values is negative, you have to think about it as minus and minus. So when I go to put the H in, drop in the 4, drop in the K, drop in my R, x minus 4, but minus and minus plus. And as you guys think about directions, 4 and -3 is definitely right and down. And think about it here, right and now down. And this is going to have that sort of same feeling like left and right felt with a parabola, where this is the way it reads, and really technically this is going down because what did you do? You went minus a -3. A -3 is definitely you're down. And I think by now, hopefully you guys got your heads wrapped around this little deal and it doesn't bother you anymore. Like, yep, I got it. There you go. Okay, so there's a shifted left, right, up, down concept plugged into the equation of a circle. Related right back to H and K again. And let's do the same thing, float back and forth between, here's the graph, write the equation, here's the equation, draw the graph, so we'll just do that again. Now, this is, again, good to remember as you're looking at it and pulling this stuff out, right? I pull out the h, so that's 4. When I pull out the k, if this is minus k, the only way this could be positive 1 is that k had to have been negative 1. Because, again, the idea would be minus a minus creates the plus. And then this is still r squared, so remember when you go to your radius, you got to take the square root of that. Again, I think you guys will find this probably super easy. I think it's one, like I said, one of the easier graphs to work with. So 4, negative 1 as my center. Travel out 4 in every direction. Plot some points to help me draw a little bit better. Oops, sorry, 4 in every direction. There we go. Draw my circle. Okay. So whether you're talking about a circle centered at 0, 0 or centered somewhere else, the drawing part is, again, pretty simple. Go out your radius in every direction, you're good to go. So the last thing we'll do is tie this back into the dilated idea. So here again is our shifted. We got the HK going on. Again, we're going to start by working with that, check out a graph, and then talk about the dilated format and how they relate. So now if I'm checking out my h, where it says plus 2, but it's minus h, then this had to have been negative 2. Again, the reason being minus a minus produces my plus. And then here, where it's minus k, then that actually is my k. R squared, so take the square root, and then go draw. So negative 2, 4, center, radius 3, 3 in every direction. Doesn't get much easier than this. Draw your circle. See if I can get to draw my circle. There we go. Okay. Now, one more time, back to the other format. So we're kind of working back and forth between these two. It's really good to relate them so you can see, like, all right, how does one connect to the other? So in this scenario, we'd have a shifted circle, move it away from the 0, 0 center, upsize a unit circle by a factor of. And what is the factor? Now, here's kind of the thing that's a little bit weird about this is, like, radius 3 in this format becomes your upsize. The h and k don't change. This part up here and here is going to look very much like it does in here. But because you know you upsize from unit circle 1 to a radius 3 by looking, I'm going to say now there's my 3. So when we go do the other version of it, you'll notice in here you'll have the x plus 2, the y minus 4, that's still there, over 3 squared. If we wanted to, we could run through that process again. I'm not going to do that because we're going to wrap this video up, but I could square everything. Like put this in parentheses, x plus 2, parentheses squared over 9, y minus 4, parentheses squared over 9, multiply through by 9, and guess where I would be? Right back here. So you can work back and forth between these two forms. I think generally this one I think just sort of makes a little more sense when you're doing graphing, but this is just how we upsize from unit circle radius 1. Okay, and that's going to do it for our circle family, and that's going to do it for chapter 3.